So moving on our question revision of the question paper that we are still on November 2025, and this time working with derivatives, differentiation. We were given on question number 2, all right, 2.1, determine dy dx in each of the following cases. And they stated that simplification not required. Whenever you are given this condition, do not simplify, just differentiate. And I said on the introduction of this part, whenever you are to answer this question, look into these properties: the power, the function, and the given expression affecting the function. Or simply to note, if the power is not given, you simply work out the outer and the inner. That is the most important thing, the outer part and the inner part, so that you can apply your derivatives in an easier way. The first question that we are given here, it is, all right, 2.11, y is equal to the ln to the exponent. There is a power there. There is a power. All right, so here I'm just going to also correct one or two mistakes that happened on our memo on the presentation. The presentation of the answer is not properly. It was not properly presented. They just missed something on their presentation. So that's the purpose of these revisions also, so that you take note of your answers on the memo. All right, so this one, there is a what? A power. The ln or the function that we have here carries a power. It has a power. So when you've got a power, you can use the PFI rule. Remember, power, function, the inner expression. So meaning to say we are going to differentiate starting with the power. We differentiate looking into the power. The power. Drop the power, subtract 1. We are looking into the power. Whatever that you have to the exponent of 3, you are going to drop the power and subtract 1 on the power. So it's going to be 3 of that to the exponent of 2. So this is what you're going to have. So that is 3 of this part, ln squared. It is now squared. All right, so we're just going to repeat everything as it is. X squared minus 5x plus the square root of x squared minus 7x plus what? Plus 20. This is what you have. Times the function. So our function, so this was our power. The function is the ln. We are differentiating what? A ln. If you are given ln x, the derivative is going to be 1 over x. If it is ln of a certain function, it's going to be 1 over that function times the derivative of the function. So it's 1 over this whole expression that you're given there. So it was going to be 1 over what? This whole expression of x squared minus 5x plus the square root of x squared minus 7x plus 20. This is what we have. Is it 20 or 10? Let me check. It's a 20, this one. All right. Sorry for that. So that's a 20. Took it as a 10 from another part. I don't know if it was a mistake or what. All right. I think, yeah, I took it as a 10. Or maybe when I changed this, because also this question paper, it was just having some issues. All right, so if it was a 20, guys, just put a 20. If If it is a 10, just put a 10. All right, so this is what you're going to have. This is 1 over the function times what? The derivative now. And that derivative, that is our inner expression now. The derivative of this inner expression, this one. Take note, guys, what you're differentiating this part. So we want to differentiate this part properly. This one. This is the one that we are differentiating. This one. We want to differentiate this properly. This is a single. This one is it's a single expression that is. We must differentiate each part. This one to this one to this one. That is the case. So if we were to differentiate this, we were going to obtain, all right, let me just put this bracket just in case. Drop the power here. So that's what? 2x. And subtract 1. And minus 5x is going to give us minus 5. Then plus this derivative of this what? Square root. So we must differentiate the square root of that. The square root of x squared minus 7x plus 10. Plus 20, I mean. Like I said, just check with your question paper, guys. So this is the same as what? To the exponent of a half. So we are back to say when we have to differentiate this condition, where it is raised to a certain power, we must consider what? The power. The derivative of what? The power. Drop the power, then subtract 1. The power first. So this was going to give us 1 over 2 of what? This whole bracket, x squared minus 7x plus what? Plus 20 to the exponent of what? To the exponent of minus half. This is the power times the derivative of the inner expression now, the one that you're having inside the bracket, this one. So you differentiate that. The derivative of what? Of x squared, that is 2x. The derivative of minus 7x, minus 7. 20 is going to be a constant. So this is a single term, this one. Under a product, we are not saying this bracket was going to end here and the 2x is outside. No, that is the error that was from your memo. This is a single term under a product. We are differentiating this part here. So it's a single term. So the bracket was supposed to be, this was supposed to be closed inside. This is a single term. This is a single term. This one is a single term since it is under a product. So we have got 3 terms that are separate here in that bracket. So that was the whole idea there. You must be very careful on your simplification at the end. All right, so this is it. I don't know if it is clear, but that is our dy dx. We have to combine everything. So that is how these questions can be given as. All right, like I say, just cross-check that one if it was a 20 or a what, because I edited these pictures later on for them to be just clear a little bit, so they can change numbers. You never know. You know these softwares, guys. Let us check 2.12. Y is equal to arc sec, all right, of x squared plus arctan of 1 minus x over what? 1 plus x. This is it. Again, simplification is not required. So in our case, we do not have the power like what we had. We have to consider the power, this and that. So we just have to consider the outer and the inner. The outer versus what? The inner. The derivative of the outer going to the inner. So meaning to say our dy dx was going to be what? The outer, that is the arc sec. Arc sec. How do we differentiate arc sec, right? This is it. The derivatives here, arc sec, it's here. This is arcsec of x is going to be 1 over x, square root of x squared minus 1, all right? So we are going to use that, all right? 1 over x, the square root of what? X squared minus 1. So this is the tricky part now when you're dealing with this derivative that you are not to simplify. The x there, remember this was sec of what? X. So we put x and x here. X, this is x squared. So what represents x is the whole part here on what? On arcsec, which is what? X squared. In place of x, you must put what is represented. If it was turned like this one will represent your x. This is what it means. So in place of x, you put whatever that is inside the bracket. If it was x squared plus 1 plus what, put as it is. So there we've got x squared. So in place of this x, we're going to put x squared. In place of x here, we're going to put x squared. So it was going to be 1 over x squared, the square root of, in place of x, you put what? X squared, but it is already raised to the exponent of what? Of 2, this one. So this is what you're going to have, 1 over x squared, the square root of exponent multiply. So that's x to the exponent of 4 minus 1. So this is what you're going to have, 1 over x squared, the square root of what? X to the exponent of 4 minus 1. So we have dealt with arcsec, the outer. Then we move to the inner. We multiply to the inner one, x squared. The derivative of x squared is going to give us 2x. So you multiply to 2x. That is the condition. So if wanted, you're going to cancel x and x, but do not simplify it. Leave it like that. We are done with the first term. So we move on to the second one, arctan. What will be the derivative of what? Arctan. 1 over 1 plus x squared. This is the derivative of what? Arctan. 1 over 1 plus x squared. So take note of what represents x. The whole part here inside the bracket is the one representing x. So meaning to say it was going to give us 1 over what? 1 plus our x is by this as it is. So it was going to be 1 minus x over 1 plus x squared. This is our derivative. Times what? The derivative of the inner from the outer arctan. Then we move on to the inner expression, this bracket. And what is it that we have inside the bracket? It is a fraction, quotient rule. We are back to the quotient rule. This is our in, u over v. So we must apply our quotient rule. The derivative of this is going to give us what? V, the derivative of u, minus u, the derivative of v over v squared. This is what you're going to have. So meaning to say, taking this formula, our v is what? 1 plus x. So it was going to be v 1 plus x times the derivative of u. This is going to give us 0 minus what? 0 minus 1, which is minus 1. All right. Minus our u. U is what? 1 minus x. Times the derivative of v. This is going to give us 0 plus 1, which is what? 1. All right. Everything over what? V squared. So that's 1 plus x squared. So that is it. We are done. This is under a product. So we can leave it like that. This is under a product. Here it is under a product. We have multiplied this outer to the inner expression. The outer to the inner expression, just like that. You're done. So simplification is not required, remember. So just leave it like that. All right. For more, I think I have a playlist for this subtopic. See where the simplification is not required. So you can go through the playlist, all right, and understand more about where the simplification is not required. It's all about revision, all right. Moving on to another part of our question, which is now that is 2.2. Calculate divide x from this with aid of logarithmic differentiation, where we must introduce the ln. So erase the ln of y, which is equal to, you introduce the ln on the other side. That's 3 to the exponent of x, ln x squared. This is what you have. All right. We need to differentiate, but looking into our right-hand side is something complicated for now to work with. There are laws under our logarithms. If we are given the ln of a to the x, or let's just take m to the exponent of n, we can drop the exponent to multiply the log of m. N can be used to multiply the whole log. This is the condition that we have on this part of the right-hand side. X, ln x squared, is the power, just like n. So it can be used to multiply our logarithm. So that means the ln of y is equal to, drop the exponent. So that's x ln of x squared times what? The ln of m, the ln of the base, which is the ln of what? The ln of 3. All right? But we can also see that there is also a ln raised to the exponent here, x, the ln of x squared. We can also do the same application, guys, here. The ln of x squared, from this condition, we must drop what? We must drop the power, just like here. So meaning to say the ln of y is equal to x times, drop the power there. So it's 2 ln x times the ln of 3. All right, this is what we have. We can differentiate. All right, so take note, 2 is a constant, and also the ln of 3 is a constant. These can be simplified. We can use our calculator, simplify 2 ln 3. So it's a constant. We can just write it as a single number, just like the ln of y is equal to 2 times ln 3. So that's 2 ln 3. We can now separate x and the ln of x. And algebraic and that logarithm, we can separate. So it's up to you. Are you going to start with x or the ln of x? So as for me, guys, I'm just going to start with x. So I'm going to put x here times the ln of x. So I have separated in this manner to say this is multiplying the ln of x. Since 2 ln 3 is a constant, it's just like 2x times cos of x. You take this one as a single term. You could have taken this as x times 2 cos of x. Is still one and the same. You take this as a single term, this as a single term. All you just need is to separate to have two different terms, u and what? U and v. So thus, on our derivative from the product rule, u, the derivative of v, v, the derivative of u. U is equal to what? 2 ln 3 times x. Remember, x, I mean 2 ln 3 is a constant. It's just like 3x. The derivative of 3x gives us what? 3. So it means the derivative of u is going to give us what? 2 ln 3. All right. Then as of v, our v represents the ln of x, guys. The derivative of ln is what? 1 over x. I think also this one you are given direct in your formula sheet. All right. Ln, remember, is the logarithm of x in base of what? E. This is the ln of x. Its derivative is what? 1 over x. So that one we can just substitute into our formula. So to differentiate the ln of y, it is not x, it's y. So it's 1 over what? 1 over y times dy dx. Remember this. And on the right hand side, applying our product rule, you're going to have what? U. What is our U? 2 ln 3 times x. All right, x is separate, this one. All right, times the derivative of v. The derivative of v is what? 1 over x. So this is times 1 over x. All right, we're going to add v. Our v is what? The ln of x. All right, times the derivative of u. The derivative of u is what? 2 ln 3. So that's it. That's 1 over y dy dx is going to be equal to, here we can cancel. Remember, this is a separate from x. So we can cancel this x and this x. It's going to be 2 ln 3 times 1, which is 2 ln 3. All right. The ln of x times 2 ln 3, you can just write this one as 2 ln 3 times the ln of x. All right. Just like that. Yes, product, you can just add these 3 plus x. It will be 2 ln of 3 plus x. You can have it that way. If you're multiplying, you add the numbers, or you can just leave it like that. It's still one and the same. All right, so this is what you have. At least you have managed to simplify the right-hand side. We want dy dx, remember, not 1 over y this. So we must get rid of this y that we see. So multiply by y both sides of our equation. That was going to cancel and give us what? Dy dx, which is y times this whole bracket that we see here, the 2 ln 3 plus 2 ln 3 times the ln of x. All right, so this is it, where y is that original term or function that we had here as it is. Sorry, before we introduced, it was here, here. Before we introduced the ln, this is our y as it is. So substitute that as it is in place of what? In place of y. You are done. So therefore, dy dx was going to be equal to what? In place of y, substitute that equivalent as it was 3 to the exponent of x, ln of x squared. All right, then you're going to take the bracket here as it is. That's 2 ln of what? Ln of 3 plus 2 ln of 3 times the ln of x. All right, any other way that you think that you could have answered the question? Guys, we have the community section. If you check the YouTube, on the YouTube application there, under Maison African Motives, visit the community so that you can even take a picture of your calculations you're working, all right? Upload that and just copy a link of this video or whatever video that you have a question on. Then you paste also with the what? With that link, so that I can refer to that video, or you can write the description of the video the way that it is written there, so that I can refer to that video back with your calculation to verify. All right? Because you might be having another understanding which is actually correct, or maybe it is wrong. So this is a platform where we can correct each other. Because under exam, guys, you know that their correction is tough. It's a tough correction because they correct you by just giving you a mark. So here, guys, we are not giving anyone a mark. We are correcting each other. It's a learning platform, a learning zone. All right, I'm not going to waste your time. Let us move on to another question, which was now 2.3, the implicity function. All right, we also have this one, I think, as an introduction. So go through the introduction, guys. Understand all the basics. you need to know all the basics. So 2.3, the implicit function, we give an x squared y plus the cos pi over 2y like this, minus 4x squared is equal to 5. So 2.31, you were asked to determine dy dx, the derivative of y with respect to x, all right? A simple question, actually, all right? Because here, what we just need is to differentiate, guys. As we heard previously, or as we saw previously, that whenever there is y, you differentiate, but you multiply by what? By dy dx. All right, so meaning to say, these are two terms. So this is a product. The first part, it is a what? A product of two terms. So we must use what? The product rule on these two. All right, x is a term on its own, y is a term on its own. That is how you play around with this one. So that was gonna give us from our product rule. All right, this is u, this is v. So if our u is x squared, its derivative is going to give us what? 2x. Then our v is equal to y. So its derivative is going to be 1 times what? This is y, guys. So we must multiply to dy dx. So that was it. Using our formula, u x squared times the derivative of what? V, which is dy dx. From what we have, 1 times dy dx is just what? Dy dx. All right, plus our v is equal to y times the derivative of u, which is what? Which is 2x. So this is it. Then cos, remember cos, the derivative of cos ax is going to give us minus a sine ax, the constant here multiplies, all right? Here they just gave us as cos to minus. So if there is the a constant here, you have to multiply it also there. All right, so that is the case of our pi over 2. This one is a constant, so it must also be visible. So it's negative pi over 2, the sine of what? Pi over 2y like this. We differentiated with respect to y. So do not forget to multiply by what? Dy dx. Okay, so that is it. We move on. Minus 4x squared, we do not have y. That's just differentiate direct, drop the power. So that's 8x is equal to a constant that's a 0 on its derivative. So this is it. Remember what we need on this derivative. We need what? Dy dx. So dy dx, we have got it. We have got this one here, and we also have got it here. So we can simply factor it out. By factoring out dy dx, you are going to remain with x squared. Here you're going to remain with minus pi over 2, the sine pi over 2y like this. You have factored out dy dx on these two terms. You have factored out. So meaning to say, you are going to remain with this one, y times 2x, that's 2xy, all right, and minus 8x. That is equal to 0. All right, so that is it. What we want is to find dy dx, so we can get rid of other terms which we do not have dy dx, which is this part here. We can take it to the other side of the equation. So meaning to say, this whole part left, x squared minus pi over 2, the sine of pi over 2y like this, dy dx is gonna be equal to, all right, taking this, all right, minus is gonna change to a positive, that's 8x. This one is gonna change to a negative, so that's negative 2xy. Okay, and we can find our dy dx by simply what? Dividing by this bracket that we see here. So therefore, dy dx is equal to, just take your right hand side as it is, all right, everything over this bracket x squared minus pi over 2 the sine of pi over 2y like this. All right, we are done. This is how we could have answered this question in a basic way. In a basic way, this is what we have. We have got our dy dx. Implicit, guys, is just basic derivative. Mathematics N5 is one of the easiest, guys. You must have a distinction in Maths N5. It's an interesting, it's interesting, yeah, it's interesting. It's just distinction, this one. Determine the equation of the tangent. All right, a tangent is simply what? A straight line. Y is equal to mx plus c. To the graph at the point, you are given the point. All right, so how do we determine the equation of what? The tangent, 2.32. All right, this is an easier part, guys. The equation of a tangent at the point 1, 2. All right, that was the point given, 1, 2. All right, the point 1, 2. So we simply need to find the equation of a straight line. A tangent is simply a straight line. So that's y is equal to mx plus c, where m represents the gradient, and that's dy dx at the given point. The point represents the value of x and the value of y. So at the given point, substitute the value of x, 8 into x. Our x is what? Our x is 1. Minus 2 times x, our x is 1. Y is what? Y is 2. Everything over what? X squared. Our x is what? 1. 1 squared. That's another mistake that the memo did. They took 2 there. No, x is 1. So that's 1 squared minus pi over 2 times the sine of what? The sine of pi over 2 times, it's like this, pi over 2 times y. Y is what? Y is 2. So this is simply going to cancel, and you remain with what? With pi. You see where this pi is coming from. All right, so that is our gradient. And in radians, we can use our calculator, or you have to convert to degrees. So pi in radians, your calculator in what? In radians. You must have R the way you see this D. It must be R. So it's shift. You go to the setup, press number 4. Your calculator is now in what? Radians. So that is the idea there. So put a fraction, 8 times 1. That is 8, guys. All right. 2 times 1 times 2. That's what? That's a 4. Over 1 squared. That's 1 minus pi over 2. The sine of what? The sine of pi. That is 4. So this is what you're going to have. So m is 4, the gradient. So given that m is 4, substitute into this equation y is equal to 4x in place of m plus c. And c can be determined as it is, as we have got a point. So we can substitute the point given here, 1, 2. And you have the value of what? The value of c. We are done. So when x is what? 1, y is 2. So 2 is equal to 4 times 1 plus c. Let's take this to the other side. It's going to be negative. So negative 2 is equal to c. So that's our equation. Can be written as y is equal to 4x plus minus 2. That's minus 2. All right. So this is what you're going to have. This is the equation of the tangent to the given curve. Just like that. Dy dx, its applications. Derivative. Dy dx means the derivative of at the given point. So the point must be substituted into dy dx to obtain the numerical value. This is gradient expression. It is the expression representing the gradient. But here we are now having the numerical value from the point which lies on that graph. So that is the idea, guys, from your revision. All right, so do more question papers where you do not understand. Like I said, the comment section is there. The community section is also there. Play around with those two There is no need for you to visit WhatsApp, guys. Everything we can end it here on YouTube. Send your questions here on YouTube. You can send them. We can communicate here. All right. Let us use this platform. Where you do not understand, communicate. All right. So that is it, guys. Till we meet again.